When the primary circuit of an ignition coil is interrupted, the secondary winding produces a high voltage which seeks a path to ground across the spark plug, center, and ground electrodes. The compressed air and fuel mixture in the cylinder acts as an insulator against current flow, and the resulting discharge of energy must overcome this resistance to generate a sufficient, precisely timed spark to ignite the mixture. There are many factors that determine the voltage required to jump the gap, including spark plug design, so let's take a look at them, starting with cylinder pressure. This voltage, known as the firing voltage, rises as cylinder pressure rises. High engine load at low speeds creates high cylinder pressure and consequently requires a higher firing voltage, which increases the likelihood of a misfire under these conditions. Lower air-fuel mixture temperatures also require a higher firing voltage, and as a result, misfires can also occur more easily on a cold engine. Spark plug electrode temperature is another factor affecting firing voltage. As electrode temperature rises, the firing voltage decreases. Electrode temperature rises with engine speed, therefore misfires occur more easily at lower engine speeds. A lean air-fuel mixture requires a higher firing voltage, so lean conditions naturally promote misfires. Spark plug gap has a drastic effect on firing voltage, and the wider the gap, the higher the voltage. As a spark plug electrode wears, the gap increases along with the voltage required to jump across it. Electrode shape is another primary factor affecting firing voltage. Electrodes with sharp edges or points require lower voltage, so this is an important aspect of spark plug design as well as the tip material. Worn spark plugs that lose their sharp edges require increased voltage, so a hard tip material which allows a spark plug to maintain its edge in turn provides consistent performance for many miles. This voltage, as viewed on an oscilloscope, is represented by the firing line or spike. This is the point at which the coil discharges. As the required spark voltage increases due to one of these contributing factors, the firing line voltage will increase. Since the spark plugs are a key factor and the precision of the ignition event is critical to maintaining performance in today's modern engines, high ignitability plugs, which are original equipment in the majority of today's vehicles, have been designed to improve ignition performance. High ignitability plugs incorporate special tip designs and precious metals and are designed to maintain the precision of the spark event and reduce quenching for more efficient combustion. The quenching effect of a spark plug is when the electrodes absorb the heat of the spark and quench it before it is able to ignite the air-fuel mixture. In other words, it prevents adequate formation of the flame core. Increasing the gap of a spark plug can prevent this, but also requires a higher firing voltage, which can exceed the capabilities of the coil. High ignitability plugs allow formation of the flame core without excessive gap, limiting the load on the coil and providing quicker throttle response, smoother idle, and better cold performance. Due to the many factors that affect firing voltage, high ignitability plugs offer different tip designs for different engines, including normally aspirated or turbo and supercharged engines. Viewing the secondary waveform during ignition system diagnosis is one of the most valuable ways to assess ignition performance, and spark plugs designed to work for your engine, such as high ignitability plugs, will keep the ignition performing flawlessly. Thanks for watching.